Higher homework, exercise 1, question 1. Find the equation of the line which passes through the points 3, minus 2 and minus 1, 6. To find the equation of any straight line, we need two things. We need a point and we need the gradient of the line. We've got 2 points, so we can choose either one of these to sub into y minus b equals m bracket x minus a. We need the gradient. We've got 2 points that lie on the line, so we can find the gradient, and it's m equals y2 minus y1 over x2 minus x1, and putting in numbers, that'll be 6 subtract minus 2 over minus 1 minus 3. 6 subtract minus 2 is 6 plus 2, that's 8. 8 over minus 4, and the gradient of this line is minus 2. We can choose either point to sub in, it doesn't matter, but let's choose minus 1, 6, and subbing into y minus b equals m bracket x minus a. That'll give us y minus 6 equals minus 2 bracket x, and we're subtracting minus 1. Tidying up, that's y minus 6 equals minus 2 bracket x plus 1. Expanding out, y minus 6 equals minus 2x minus 2. Rearranging in the form ax plus by plus c equals 0 gives us 2x plus y minus 4 equals 0, and that's the equation of the straight line for question 1. Question 2. Find the equation of the line passing through 4, 7, which is parallel to the line y equals 2x plus 3. Well, we know that parallel lines travel in the same direction and that they've got the same gradient. So the gradient of the line that we're looking for is also 2, and we have a point, 4, 7, so it's y minus b equals m bracket x minus a. We've got the two things we need, point and gradient, and it's y minus 7 equals 2 bracket x minus 4. Expanding out, y minus 7 is equal to 2x minus 8, and rearranging in form ax plus by plus c equals 0 gives us 2x minus y minus 1 equals 0, and that's the equation of the line for question 2. Question 3. Find the equation of the line which is perpendicular to the line y equals 4x minus 3 and passes through the point 5, 2. Well, we know that the gradients of perpendicular lines multiply together to give minus 1. The gradient of this line is 4, therefore the perpendicular line must have a gradient of minus 1/4. So we flip over the 4, that becomes 1/4, and invert the sign, minus 1/4. So we've got the gradient and point, and it's y minus b equals m bracket x minus a. Subbing in, y minus 2 equals minus 1/4 bracket x minus 5. We can multiply through by 4 to get rid of the fraction. 4y minus 8 equals minus 1 bracket x minus 5. 4y minus 8 is equal to minus x plus 5. Rearranging in form ax plus by plus c equals 0 gives us x plus 4y minus 13 equals 0, and that's the equation of the straight line for question 3. Question 4. A straight line makes an angle of 45 degrees with the positive direction of the x-axis and passes through the point minus 1, 4. What is the equation of this line? Well, we've got our point. To find the equation of the line, we need to find the gradient. We should know that tan theta is equal to the gradient, where theta is the angle made with the positive direction of the x-axis. In this question, theta is 45 degrees, so it's tan 45 degrees. From our knowledge of exact values, that is equal to 1, so the gradient of that line is 1, and it's y minus b equals m bracket x minus a. Subbing in, y minus 4 equals 1 bracket x, and we're subtracting minus 1. Tidying up, that's y minus 4 equals 1 bracket x plus 1, and expanding, y minus 4 equals x plus 1, rearranging in the form ax plus by plus c equals 0 gives us x minus y plus 5 equals 0, and that's the equation of the straight line for question 4. Question 5. Show that the points A, B and C are collinear, where A is the point minus 4, 3, B is minus 1, 1, and C is 2 minus 1. Well, for collinearity we need to prove two things: that we have a common point and that we have equal gradients. So if we first of all find the gradient of AB and sub it into y2 minus y1 over x2 minus x1, that will give us 1 minus 3 over minus 1 subtract minus 4. That's minus 2 over minus 1 plus 4, and that is minus 2 over 3. So for BC, this time subbing in, we'll get minus 1 over 2 subtract minus 1. That's minus 2 over 2 plus 1, which again is minus 2 over 3. We've got a common point here, which is B. So we make a statement that collinearity exists since gradients are equal and there is a common point B. And that's the solution for question 5. Question 6. A triangle XYZ is formed where x is the point minus 4, 2, y is 6, 8, and z is 2, minus 2. Draw a diagram for this one. Part A. Find the equation of the median passing through x. Well, the red dotted line represents the median. Remember, a median is a straight line. It comes from a vertex, in this case it's x, and cuts the opposite line, yz, in the middle. So we need two things to find the equation of a median, which is a straight line. We need a point, we've already got that, and we need the gradient. We can find the gradient if we have 2 points that lie in a line, and we can find our second point because that is the midpoint of yz. So if we find the midpoint of yz, remember that is an average of the x and y coordinates, we'll be able to find a second point that lies on the line. So that'll be 2 plus 6 over 2 for the x coordinates, and minus 2 plus 8 over 2 for the y coordinates. 2 plus 6 is 8, 8 over 2 is 4, minus 2 plus 8 is 6, 6 over 2 is 3, and the midpoint is 4, 3. We've now got 2 points that lie on the median, so we can find the gradient of the median, and y2 minus y1 over x2 minus x1, 3 minus 2 over 4 subtract minus 4, and that gives us 1 over 8. So we can choose either one of these points to sub into y minus b equals m bracket x minus a. Let's choose 4, 3, and we've also got the gradient, which is 1/8, so it's y minus b equals m bracket x minus a. Subbing in, that will be y minus 3 equals 1/8 bracket x minus 4. We can eliminate the fraction by multiplying both sides by 8. That will be 8y minus 24 equals 1 bracket x minus 4. Expanding, that will be 8y minus 24 equals x minus 4. Rearranging the form ax plus by plus c equals 0 gives us x minus 8y plus 20 equals 0, and that is the equation of the median for 9A, question 6A.